Welcome to GITech Limited. We are an online platform dedicated to creating civil and structural engineering content. Our contents are well researched. We carry out design services, online training, through self-explanatory step-by-step tutorial courses. Our scope span across reinforced concrete and steel structures. We focus on first principle design approach and subsequent application of various structural engineering software. We are committed to creating educational video content in structural engineering using CAD software. Make GITech platform your favorite channel. God bless you. Hello everyone, my name is Engineer Ndifreke Okon. In today's lesson on structural design, I will be taking you through the process of preparing a general arrangement for a one-floor story building. And before we go into the demonstration of how to prepare general arrangement, let us consider what the general arrangement is in structural design. A general arrangement is a layout of a frame structure that clearly indicates the position and location of structural members such as column, beam, floor, slab panel and thickness on which the design of the structure is based upon. From this definition, we have come to see that general arrangement is simply a layout of a frame structure in which we can clearly see the location of columns, the location of beams, the floor slab panels and the assumed thickness on which the design of the structure is based upon. So it is also an important aspect of the structural design process as it provides a framework for the detailed design of individual components and ensure that the structure will meet the desired performance criteria and functional requirement. Then in summary, we can say that the general arrangement is a key element of the initial planning and conceptual design phase of a structural project, and it laid the foundation for the more detailed design and construction phases that follow. So now let's go into the demonstration of the general arrangement using a one-floor story building. Now this is a typical architectural drawing for one floor. This is the ground floor and this is the first floor. We are going to use the ground floor to prepare the general arrangement of this project. The reason is the first floor will sit on top of the slab of the ground floor. So it is the ground floor that will be used to prepare the general arrangement. So let's start. So you copy the architectural drawing, and you go to the structural drawing template which I have created already. And allow it to paste. So it has been pasted. So you copy the ground floor. Since we are going to use that in preparing our GA, so you pick up drawing sheet. I will create a different video on how to prepare drawing sheet. So this one is what I have already prepared for one of my structural design. So I'm going to use this drawing sheet to I'm using it for this design. So allows control the drawing so that it can comfortably enter the sheet. So the architect has already provided the grid lines, so we are going to work with the existing grid line provided by the architect. So what we are going to do, since we are preparing a frame structure according to the definition of our general arrangement, so we are going to delete all the architectural dimensions and all the features in the architectural plan in order to enable us prepare our general arrangement. So we have to delete all these things out. In structural design, we don't need all these interior information. Sorry. So we delete them out so that we can create individual panel for the floor slab. So all these will be moved. We remove all these. Taking time to do this so that you can see how a general arrangement is being prepared from an architectural drawing. So we have to be patient as we go through the process together. So that at the end of this class, we should be able to produce and prepare the general arrangement of any architectural drawing that is being given to you. So this will be removed, this will be removed, then this line will be extended to this. So you click on the line, you go to home, you click on extend. Remove this. don't want to skip the process so that you can follow from the beginning. To the end. So you delete this, delete this, delete this. We don't need it. We don't need this. Since all this information is already in the architectural drawing, and the structural drawing will be read in conjunction with the architectural drawing. So all this information are there in the architectural drawing. So in structure, we don't need them. So you click on that line, come to, okay, let's delete this first, delete this, then go back, click on this line, go back to your extend, click on your extend. So we have extended the line to this other wall. So you delete this out, delete this, then extend this line as well. Extend this. Delete this, delete this one also. Click on that line, then click on extend, click on this other line, and extend to this line. Click back, then go back to the other line and now extend this. You can remove this. We assume that it's not a structural wall, so it should be removed. everything has been joined together. So the next thing we will do right now is to reduce the thickness of this line. The thickness of this line. So you click on the line, you come to where you have this line width. You click on the line width. You go to by layer. You can as well change the color. So I will make mine white. So after doing that, you click on match property and the entire line width will be reduced to by layer and the color change to white. Okay, in structural design we work with center line. So the next thing we will do right now is to create the center line. And before we do that, let us check the size of the block. Let's check the size of the block. The size of the wall. So you click and check, this is 225 wall. So center line will be 112.5. 112.5. So you go to offsets. You go to offsets. You type 112.5. On escape. We are going to extend this line to it. Remember, this is our center line. The next thing is for us to insert our column. Insert our column. As you can see, the thickness of the wall is 225, so our column size will be 225. Except after design, if the 225 size of the column is not adequate, we can effect the changes. So but for now we will go with the 225 column. So for you to create your column, you click on line, okay, let us use polyline to create our column, so that when we export this to total structure, those lines will come out. So you go to your polyline, you click on polyline, you click and you type 225, click OK, take it to the right, type 225, click OK, take it up, 225, click OK, take it back, then you go to hash, click on hash, dialog box will come and click on solid, then you click and escape, copy, right click on the object, you can click at the top left corner of it and click on the top left corner of the wall. So this is how to position your column. Okay, so we are done with placement of column. The next thing for us to do is to define our beam size so I will just copy this since I already have it in my template. I'll paste it here. I can change this to pave B1, meaning floor beam 1. So the width of the beam is 2 to 5. The depth of the beam is 450. So I will copy and paste on all the horizontal beams. So you go back and name this beam floor beam 1. So we can call this floor beam 2. We call this floor beam 3. We can call this floor beam 4. Call this floor beam 5. We can call this floor beam 6. Then this is not a structural beam, so you can remove that. The same is applicable here, can be removed. This is floor beam 6, so we call this floor beam 7. You can call this floor beam 7. And call this floor beam 8. I think we are done with naming all our horizontal beams. We are done with naming all our horizontal beams, so we go to the vertical beams. You can choose to start naming of your beam from the vertical. It depends on what you want. So there is no straightforward rule that you must start from the horizontal beam. So it depends on how you want to name your beam. So you can start from the horizontal beams. You can equally start from the vertical beam. So it depends on what you really want. So that is beam 8. So we can call this beam 9. Beam 9. So let's copy and paste on all the horizontal beams. These are beam 9. We can call this beam 10. We can equally call this beam 10, since they have the same span. Though the load on it differs, but it might not cause any much different. So we call this 11. Call this 12. 12. We call this 13. We call this 14. So we have total of 18 beams in this layout. Total of 18 beams. So you save your work. Always remember to save your work. So the next thing that we need to do is to define our floor slab panels and assume thickness. The reason I said that it is assumed thickness is that we can actually know the real thickness of the slab after we are done with the design. So what we are doing right now is to prepare the layout that will help us in carrying out our design. So I will just copy this information from here first. So the thickness is assumed thickness. So after we might have done our design and check for deflection, that is when we know if the assumed thickness is okay or not. So if it's not okay, we can effect the changes. So this is a cantilever, and from my experience, this 150 will not be adequate here, so I will increase the thickness to 175, but I will still need to do the design before I will finally adopt that thickness. So this is, we may call this panel 1, call this panel 2, call this panel 3, call this panel 4, call this panel 5, call this panel 6, and this panel 7, call this panel 8, call this panel 9, and call this panel 10. So we are done in naming our beams. So let's go back and find out what are the features or components of a typical GA, so that to see if we have been able to capture everything. So let's go back to our slide. Component of a typical general arrangement. Grid lines consist of grid line and dimension of the layout. So when we go back, you check that you have what? You have the grid lines and dimension of the entire layout. So let's go back again. Column position, beam location, staircase location, slab panels and thickness. So you go back and check. So we have our column positions. We can extend this. So we have our column position, we have the floor slab location, the staircase, the slab and the thickness. So we have been able to use this architectural drawing to produce a typical general arrangement. So I want to sincerely appreciate you for watching my video.